All right, so today we're going to just talk about the applications of these parametric equations. You do have one more practice problem on the homework tonight that you just have to sketch the graph, but most of what we're going to do today is applications. I'm going to start, is this maybe something B? 19B? Okay. Everybody find 19B? Okay. I think I said to have 19A and B out, didn't I? Anyway. All right, so we need to fill this in, and somehow I don't even have my slate hooked up. Let's pause the recording. So we are putting into our calculator x of t, remember how the calculator looked like this, and y of t. Does that sound familiar when you're going to put it in the graphing place where it says y equals? All right, x of t is the component that takes things across, and the formula is v sub 0 times t times cosine, because it's x, of the angle theta. And the vertical component is more like we did when we did the throw-up problems. We're generally gonna use negative 16 t squared plus v sub 0 t sine of theta plus h sub 0. I know that's complicated. Anybody have your reference sheet handy? You don't have to all grab it right now, but this is what it looks like on the reference sheet, okay? Wait, here. On your reference sheet, it shows this is what you're putting in. Okay, the t is out front here. Doesn't matter, as long as you remember there's a t on that term. But does that look like what we just wrote down, guys? Okay, so that's on your reference sheet. So don't get confused. Use your reference sheet so you have it. Now, the negative 16t squared is only when you're talking about feet per second. If it was something else, if it was in meters per second, you would use this, and I think it would, you put in a 9.8 for g, and this becomes negative 4.9 instead of 16. But look, even right here, I think on your reference sheet, I spelled it out exactly what you need. Okay, so don't panic about memorizing this. All right, let's just get right into this. So go to the bottom of 18B, where there was a question about Luigi. We skipped this yesterday. It says Luigi's kicking a soccer ball. He kicks the ball with an initial velocity of 35 feet per second, so v sub 0 is going to be 35, and an angle of 48 degrees. Theta is going to be 48. Please don't mix those up, okay? And the ball is 2 feet above the ground when he kicks it, so the initial height is 2 feet. How far will the ball travel horizontally before it hits the ground? Okay. So the formula for, I'm going to put the t out front because I think then you won't forget it. You can do 35t cosine of, or you can put the t out in front, cosine of 48. Okay, so I'm plugging these in. We just said it's initial velocity times time times the cosine of the angle. All right, anybody know what we're going to put for y then? What did we just write down? This is feet per second, so we're going to use negative 16t squared. And then you could do 35t, or I'll put t times 35 times the sine of the angle. Because it's y, we're using sine. And then we need the initial height on the end. Now you will need to close the parenthesis on the cosine and sine. Can you read that, guys? Do you need me to get rid of Luigi in the background? I could probably move it down here, I don't know. Ah! I don't know if that's any better, but that's what goes on that blank. Okay, so let's try typing it in. We needed to make very sure that you're in degrees and parametrics. And then when you go to y equals, we are going to put in here t. It has to have a variable t. And then the initial velocity was 35. And then we have cosine of 48. And cosine goes with the x. And then the y is negative 16t squared plus the same thing we just did, but sine. So t 35 sine of 48 degrees. And then sometimes there's no initial height, but this one had a 2 on the end for the initial height. Everybody got it? I feel like a lot of you aren't doing this. Okay, when we go to window, T is time. It does not take a soccer ball hours to come down, right? This is minutes, or it's actually in seconds, I apologize. It's in seconds. So I would start fairly small because you can always add time, but if you put too much time in, the calculator just takes forever. I don't know, does 3 seconds seem okay? Maybe 4? X is the distance away from you. Anybody want to throw a number out there? How far do you think? Remember, because X is going across. I'm going to leave a little negative, even though the soccer ball is not going to go behind us. But I don't know. What do you think? 40 feet away? 50 feet away? All right. And then the Y is the height up in the air. I don't know, 20. I don't think it's going to go more than 20. All right, so I'm going to try mine and see what I have. Ooh, not bad. I'm going to change my feet away from me to 50, I think. Okay, so I'm liking this window. So let me move this graph to our notes and window. But sometimes you're just going to have to mess around and try the window. Okay. Now this is where some students get very confused about what it's asking. Let me write down what we did. We did 0 to 3 for time because it hit the ground by then. It wouldn't be wrong if you had more, but 3 was plenty. And I did -5 to 50 and -5 to 20. Again, the only reason I did negative is so that I can see the axes. Everybody okay? Somebody need help? All right. Now we can trace. It says, find the time until the ball hits the ground, which means the height is 0. What's height, guys? X or Y? Y. So we want Y to be 0. So if we go to our calculator and we hit trace, the only option in parametric mode is to go forward in time, and we want the Y to be as close to 0 as we can get. Now, this one turns out we can get pretty darn close. Did somebody else get this value? Okay, so I don't think we need to get any closer than -0.0. So how far away is the ball at that point? 39.8 feet away, right? So that's the X value. And how long did it take to get us there? 1.7 seconds. All right, so let me, what did they actually ask us? Find the time the ball hits the ground. So we made the y equal as close to 0 as we could, and we got 1.7 seconds. Determine the horizontal position of the ball at this time. Was it 39.8, guys? Is that right? 39.8 feet before it hits the ground. How high did the ball get? Okay, so if we go back to the calculator and we try to find the maximum what? Remember, you can only trace backwards and forwards in time, so we're trying to find the highest y value. I got a 12.6. Does that seem close enough? Okay. So I'm going to put 12.6 about feet. Okay. Will it clear a 6-foot defender standing 35 feet away? Any ideas what we want to make this happen? How we want to check this out? Okay. How do we get, which value do we want to be close to 35? X. So we want X to be as close to 35 as we can make it. So if I trace forward in time till X is as close to 35 as I can get. Okay. Now, this is where we're going to practice a little cheater math here. Not really. It's past 35 feet, just a little bit, right? The only thing we're allowed to change is time. It's right now counting by tenths. If I wanted to try a shorter time, I could say like 1.49 seconds. And there it's about 35 feet. It's not going to get exactly 35 feet, but either way, if you had just traced and gone, it was pretty darn close to 35 feet, and it's about 5 feet in the air. Okay? You can put in hundredths of seconds to try to get closer to the value you want, but we'll worry about that more on another question. But right now, at 35 feet, the ball's about 5 feet in the air. So at 35, I don't remember what it was, point what, we got about 5 feet in the air. So will it clear a 6-foot defender? No. I'm thinking it's going to hit him in the chest or the face or something, yes? Okay. All right, let's try some more questions. Go back to 19B, and we're going to finish the ones here. Let's see, is there 3 or 4 questions here? 1, 2, 3, 4 of them, right? Are they all in feet per second? I think they are. All right, so let's do 2 together, and then I'll have you split up and do the last 2 with a partner, okay? Anybody care? Do we want to do throwing a ball, tennis ball, lacrosse, or football? No preference? The first one? Okay. Julie's throwing a ball at initial velocity, so this is our V sub 0, and an angle of theta is 56 from a horizontal height of 4 feet, so this is our H sub 0. So someone tell me what we're putting in for X of t. Use the reference sheet. Okay, or you can put the t up front, so I'll multiply, it doesn't matter. And then for y, or y of t, if you're using your calculator, it'll say y of t, always starts with negative 16 t squared plus, same thing, 28 t sine of 56. And this one had plus 4. My mistake, hopefully you won't make a mistake at all, but my mistake is I sometimes forget the t on this term right here, so be careful. All right, so let's go type that in so then we can figure out what we want to do for the window. I already forgot. 48, 28, T, oh, let me try that again. 28, T cosine of, was that one 48? Nothing was 48, off power. Okay. And then this one was negative 16t squared plus, and again, you can put the t in front or in the middle here, doesn't matter, sine of 56 plus 4. All right, maybe I'll just try the window we had. It's not horrible, right? What do we need a little less of, maybe? How do I get rid of some of this space here? Yeah, lower the x max. Maybe I'll try 35. You can do whatever. I'm just trying to make mine nice and big so you can see it. We could change, I just want to show you what happens, guys. If you change the window to 1 second, look what happens. Does the ball stop in midair? No, but we stopped graphing it in midair because we didn't give it enough time to continue its path, okay? So 2 seconds might have been enough for it to hit the ground. But, all right, so write down the window, and I don't remember what I just have. 0 to 2, negative 5 to 35, and negative 5 to 20. And your window can be bigger, it's fine. I don't even remember what I just said. Was it negative 5 to 20 for up at the Y? All right. How far away will the ball land and how much time before it lands? So this is an easy one. We only have a couple quick questions. Okay. So if we trace forward in time, we want the height to be 0. I got 0.18. That's pretty darn close to 0. If I wanted to go a little further, if I do one more tick, it's 3 feet underground. If I wanted to try like 1.61 seconds, just a little tiny bit more time, now it's still underground. So I'd say we're pretty darn close to 25 feet away. Is everybody going to get the same answer? Not exactly the same decimal, okay? I will assume that you're going to be close, but so 25 feet or 25 point something, 25.1, I'm not going to be super picky there. How much time till the ball lands? So we already figured that out, didn't we? About 1.6 seconds. Is there one that has a lot more questions? Number 4 has quite a few questions. Is that what you're telling me? All right, so let's try 4. Football is kicked from the ground. So what is our initial height? Our initial height is just 0. 55-degree angle, that's our theta. Initial velocity of 50. So the x equation, somebody quickly. 50 t cosine of 55. Nicely done. And the y, sine, right? Yep, sine of 55. And there was no initial height, so you wouldn't need anything there. Kicking a football, I don't know, I might go 3 seconds on time. And I think further away, what do you think? X, I might make like, I don't know. It's probably not even enough. I don't think super high. I might leave this 20 or 25. And you can make those zeros negative 5. I probably won't change mine. Okay. What was it again? 50 first and then 55? and no initial height, okay? And I'm gonna try a bigger number here, and I might leave the other one. Whoa, it goes a lot higher than I thought. Does someone else's go a lot higher? Okay, so try 60 feet in the air and 100 feet away. Did that work? No, yeah, got too much. Doesn't go six stories in the air, but all right, that looks pretty good to me. You can have whatever and it won't be wrong as long as you can see it. So I think I wound up changing this to 100 and this to 40. And I had these at -5s instead of zeros, but that's a comma. All right, what is the maximum height of the football? Can you find the maximum Y value? Now, there is no way to calculate this. You just have to scroll around and try to get as close as you can. Anybody? 26.2 was the tallest I got. Close enough. That's not what it is. I was going to read that wrong. And that was a Y value. Okay. What is the horizontal distance by the time the ball reaches its maximum height? Okay. So what is X at that maximum? 37.3 feet. And just to remind us, that was when Y was 26.2, our maximum, okay? Anybody have a question? Not getting this to work? Adriel, you good, or is it not? Okay. If the ball was kicked toward a 10-foot field goal post that stands 65 feet away, will the ball pass over the post? So we need to figure out how to make X as close to 65 feet as we can. I got 66. I need a little less time. I need it to not go so far. So what would be a little bit less than 2.3, guys? 2.28 or something, 7? I'm trying to get 65 feet away. 2.25. I don't even know if it's close to hitting the goalpost. It really doesn't matter if it's clearing it by a lot. 2.27 seconds is about as close as I'm going to get. Okay, how tall was it supposed to be? Ooh. Is it going to clear? Barely? Looks like it'll barely clear. If we had not done to the nearest hundredth, what was the closest we would have gotten? See, at 66 feet away from us, it's down to 9.6. So this is one that you wouldn't be able to tell very accurately unless you got a little bit closer on the time. So as close as 65, it's just barely clearing. All right, so I'm going to copy that over onto here. And as close as 65 feet as we could get, it was at 10.5 feet up, so barely clears. Okay, so do you understand what I did with the hundredths thing? 3 seconds, or 2.3, it had passed the 65 feet, so I wanted to go a little bit less than 2.3, so I tried some hundredths. And I'm not going to necessarily put one on quiz, you have to get that accurate, but all right, I'm going to stop the recording for a minute and ask you guys to work on 2 and 3, and then I'll put the answers up here on the record. All right, so for number 2, I took the time to put the equation down, put it in my calculator, find a window. Then it said, how far away will the ball land if it's not hit? So I want to trace out till it hits the ground. It's between 1.6 and 1.7. What is a good time to try between 1.6 and 1.7, guys? If it was dollars, you'd have $1.60 and $1.70. What's in between there? 165. That's pretty darn close to zero, right? And okay, so I'm going to put that one on the screen. And what was the question? How far away will it land if it's not hit? About 46.6. And if you got a slightly different answer, that's okay. Feet away. What is the approximate height of the ball at the net if he's standing 20 feet away? So when x equals 20, what's y equal? So can we get x close to 20? So that's close to 20. We could try like 0.71 if we wanted. I'm not going to be picky. There, that's pretty darn close to 20. So I got it's about 11.5 feet in the air. And if you weren't that exact, it's okay. So 11.5 feet was approximate height if at the ball at the net. Okay, so that answers all those questions, right? And then this one was a little different. You had to put it in. Was it a 70 and a 20, guys? And did it have an initial height? .5 was the initial height? Okay. How much do I change my window? A lot, lengthwise. So maybe, what? Oh, I really don't need to hit it, have it come down, right? Because it's only 1.6 seconds, yeah. So I changed the window a little, but it's not that big a deal because it only goes along until the ball is caught at 1.6 seconds. I got that. Did someone else get that value? Or did I type something wrong? So at 1.6 seconds, I got that it was 105 what? Is the 105 horizontal or vertical distance, guys? After 1.6 seconds, how far had the ball traveled? Is anybody awake out there? Which one's distance away and which one's height? X is distance away, so it had traveled about 105 plus feet. And the height of the ball when it was caught was about 3.8 feet. Okay, is that reasonable with the lacrosse stick to be 3.5 feet off the ground? Seems like it would be okay. All right, feeling okay about this? Pretty easy stuff, okay? More practice on parametrics was the worksheet you're supposed to pick up in the back, and you have the rest of the time to work on that. And I just saved all that ink on there over the top of it because I forgot to rename it. And I forgot to stop.